When you're doing algebra, you'll come across expressions and equations where there will be many things with variables adding and subtracting. We can simplify these things as long as they're what's called like terms. Before we do any of that stuff, let's define what a term is. It's really just a packet of numbers and variables, all multiplying or dividing together. Normally, they're just multiplication, division. Sometimes you'll see addition and subtraction within it, but they're going to be locked within parentheses. And we typically do other things with them to remove that, that parenthesis group there, which I'll show you later on. So first off, 2x here is the same thing as 2 times x. We write them right next to each other to remove having to write the multiplication symbol, since so many times there's multiplication happening. You can also think of this as repeated addition as x plus x. So 5x is really 5 times x, which is really just x plus x plus x plus x plus x. So for instance, if we were to do something like 2x plus 5x, if we had that expression, well, this is really just x plus x for the 2x plus the 5x. But really, these are all just the same thing. You can think of x as like 2, right? This would be 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. And that would end up being just a total of 7 2's. In this case, 7 x's, which is just 7x. And you can think of this as really just 2 plus 5 times x. All I did there is I combined the like terms. 2x and 5x are like terms because the variable part, not the coefficient part, the number in front is called the coefficient. The variable is just all the variables. The variable part has to be the exact same. In this case, 2x and 5x, they are the same. In the next case, we have 3.423 times x times y squared. The next one is negative 15 times x times y squared. You can see that the variable part, x times y squared, these are like terms. The number, it doesn't matter to see if they're like terms or not, just the variable part. So if these were adding, subtracting, we could actually do that. Now the next two, 3x squared and 3x, this is really just 3 times x squared, which you can think of that as 3 times x. And the 3x is just 3 times x. You can see fundamentally the variable part is different. Therefore, these are not like terms. So if I was to do something like this, like 3x squared minus 3x, I could not combine these things. I would have to just leave it in this expression. So as I said before, when we have like terms, we combine them by adding or subtracting the coefficients, whichever way they're written down. The context is important here. When working with expressions with like terms, it's helpful to group them. And when you're first kind of learning this topic, it's helpful to group the ones that are like terms together so that you can see easier how they interact. Let me clean this up a little bit. That was a little better. Okay, 3x plus 6x. These are like terms because the variable part, x, is the same. And we have 3 plus 6. So 3 plus 6 is 9x. For this one, I'm going to rearrange the terms. I'm going to move the 5x here and move the 7x, and then, yeah, that's all I actually need to do. If I move the 5x, then you're going to see 8x, and it's going to be minus 5x. The negative is on top, on the 5. Then we have plus 4y minus 7y. And now we have like terms kind of grouped together. 8x minus 5x, those are like terms. 8 minus 5 is 3x. And we have 4y, do different, 4y, negative 7y. Those are like terms, the variable parts are the same. 4 minus 7 is negative 3, with the y. Okay, the next one you see we have 10x and minus x. These are like terms. 10 minus 1, we can think of this as 1x, negative 1x. 10 minus 1 is 9x. Negative 9x plus x. This is just the same thing as plus 1x. Negative 9 plus 1 is negative 8. All right, like terms here, let's group them up. I'm going to get, so we have 13, so I'm going to move this negative 2 right here. I'm going to move this negative t in front of that 6y. That gives me 13 minus 2, then plus 5t minus t plus 6y minus y. 13 and 2 are like terms because they both have no variable part. 13 minus 2 is 11. 5t, so typically we do this with different so you can see the you know, kind of like the rounded curves that I did here. Those are like terms. The straight bars is like terms, and the double straight bars are like terms. So 5t minus t, that's going to be 5 minus 1. 5 minus 1 is 4. So it's going to be plus 4t. And 6y minus y, or minus 1y. 6 minus 1 is 5y. A minus 4a. A is really just 1a. So we have 1 minus 4 is negative 3a. All right, last one here. Instead of rearranging it, I'm just going to look at it and look for like terms. I see that I have 8x and negative 5x. I have 3 and negative 1. And 2y and negative y. 8 minus 5 is 3x. And then here I have 3 and then negative 1. Those are like terms. So we have positive 3 minus 1. Positive 3 minus 1 is positive 2. And then we have plus 2y minus y. 2 minus 1 is 1. So just plus y. And so you don't need to rearrange them if you know what you're doing. You can, of course, just rearrange them if you feel that that's easier for you to understand. That's fine. Whatever way you're comfortable doing. Just so as you know, typically we write the numbers that are by themselves last. So probably the more mathematical way of writing this is 3x plus y plus 2. You really want the number by itself last. That has to deal with polynomials, which you'll learn more about if you take higher levels of mathematics. Okay, sometimes you'll see expressions locked within parentheses. We can't combine any like terms where one part is on the outside of the parenthesis and the other part is in the inside. To fix this, we use the distributive property to remove the parentheses. If there is only a plus in front, then we are effectively distributing a positive 1, which changes nothing. So you can actually just drop the parentheses there. So for instance, if I had 2 plus 3 minus 7x, the plus parentheses here, really, that's effectively just dropping the parentheses. It's the exact same expression that you get the same result. So if there's just a plus, feel free to just drop the parentheses. If there's a minus in front, as we have here in this first one, we're distributing a negative 1. Just imagine there's a 1 right there, and distribute a negative 1. In other words, multiply everything on the inside by negative 1. What you'll see is all that happens is everything on the inside changes signs. If it's positive, it'll go negative. If it's negative, it will go to positive. If a number is present, then you actually distribute that number and multiply everything on the inside. After you do this, you will always combine like terms. You always want to combine like terms whenever possible. It makes the problem simpler and easier in general to work with. Let's keep going. This is completely solved. There's no like terms there. Distribute the negative, we get negative 5x minus 7. This is solved because there's no like terms. In this case, we distribute the negative to three things. We have positive 2x now, positive 6y, and minus 4. And that can't be simplified any further. Distribute the negative here, we get negative 10x plus 17. No like terms. Here we're distributing a negative 2. So we have negative 2 times 4. You always multiply the coefficient. Negative 2 times 4 is negative 8. And just add the variable to it. Negative 2 times positive 8 is negative 16. So I just multiplied everything on the inside by negative 2. Okay, for this one, we see we have like terms here, 6y and negative 2y. But the negative 2y is locked within the parentheses. So the first step is to get rid of the parentheses, and then we can combine like terms. So distribute the negative into there. The 6y is still the same, that hasn't changed. But now we have negative times 5x is negative 5x. Negative times negative 2y is positive 2y. And negative times positive 8 is negative 8. I just flipped the signs on the 5x, negative 2y, and positive 8. Okay, combining like terms, we have 6y and 2y. I'm going to write the negative 5x first. 6 plus 2 is 8y. We have minus 8. I'm just writing it to where the variables go down in alphabetical order, and the number by itself, with no variable part, is last. That's the typical mathematical way of writing it out. Okay, we do have like terms on the outside here, 3a and 2a. 3 plus 2 is 5. So we could write this as 5a. And I'm going to distribute this negative into here, giving me negative 5a minus 6. And now you see I can combine these like terms. 5a minus 5a is 0. In other words, they cancel. So we really just get negative 6. Okay, we can distribute the negative here, giving us 5y minus 2 minus 2y plus 4. Now we have 5y and negative 2y, negative 2 and plus 4. So 5y minus 2y is 3y. 5 minus 2 is 3, and we have y. And then negative 2 plus 4 is positive 2. And this can't be simplified any further. There's no like terms. Distribute the negative 3 into there. We get 20a. Negative 3 times positive 6 is negative 18a. Negative 3 times negative 2 is positive 6. Now we have like terms, 20a and minus 18a. So we're going to subtract 20 and 18. 20 minus 18 is 2a plus 6. Okay, this one here, there's quite a bit of distribution we have to do. I'm not going to worry about, well, you always kind of start with the innermost distribution that you can. In this case, we can see we can distribute the 3 into there. The 4 can be distributed there. And the negative 3 can be distributed there. We're still going to have these brackets on the outside, which is the same thing as parentheses. It's just a different symbol so that you know the brackets go together and the parentheses go together. But they're handled the same way as parentheses. So first off, we have 3 times x is 3x. 3 times 2 is 6 plus 2x minus 4 times y is 4y. 4 times 2 is 8. Then we have negative 3 times y is negative 3y. Negative 3 times negative 2 is positive 6. We've got some like terms we can combine. So we get 3 plus 2 is 5x plus 6. 4y minus 3y is just y. It's just 1y, or in other words, just y. And plus 8 plus 6 is plus 14. Now, these parentheses in front, or these brackets in this case, they don't mean anything because there's nothing written there. It's equivalent to just saying it's a positive 1, which doesn't change anything when you distribute it. So we can actually just drop the brackets. The next pair, however, we need to distribute the negative into there. That gives us 5x plus 6 minus y minus 14. And now you see we have like terms again. 6 minus 14 is negative 8. 5x minus y minus 8. So just to recap, if you have parentheses or brackets in this case as well, distribute as much as you can possibly, and always combine like terms whenever possible. You can only combine like terms if they're contained within parentheses or there's no parentheses at all. As you see, I could combine like terms here and here, but I could not combine these like terms together until this last part here when the parentheses were completely gone. That's because this 6 here was not contained in these set of parentheses. I could, however, combine these like terms because they are contained within the same set of parentheses. If that's confusing to you all, just expand all the parentheses out until you get nothing left. Just distribute everything out until you don't have any parentheses anymore. And at that point, you should have a bunch of like terms you can combine. And definitely combine them. Whenever you can, combine like terms. It makes the expression simpler, which is just nicer to work with.